With KembloX I learn easily when I study chemistry. Chemistry for you and me. KembloX does the trick for me.
In this segment, we are going to talk about dissolution and solubility. We have two tasks in this segment. One is to present a new solubility guide in the shape of a logical decision tree, and to clarify the manner in which ionic compounds dissolve. Compounds are considered soluble in water if they form a homogeneous mixture with water, called solution. In this case, water is called the solvent, while the compound is called the solute. The process of formation of the solution is called dissolution. Due to the ubiquity of water, most of the time water is not explicitly mentioned, i.e., the terms solubility and dissolution imply in water unless other solvents are specified. Based on the UPAC definition, ionic compounds are described as insoluble, slightly soluble, or soluble according to the amount that can be mixed with water. Quantitative data for specific compounds can be gleaned from specialized tables. To reckon whether an ionic compound is expected to be soluble, people use general trends presented as solubility charts or solubility guides. Along these lines, I created a visual decision tree solubility guide to help with deciding whether an ionic compound is expected to be soluble, slightly soluble, or insoluble. Starting with the formula of the ionic compound, in green on the chart, the first question is whether it contains any of the solubility-inducing ions, nitrate, chlorate, etc., or ammonium group 1 cations. If so, then the compound will be soluble. If it doesn't, then we go to the next question, for example, whether it contains chloride, bromide, and iodide. This will be in the affirmative. Then there is another question, whether it contains any of the silver, lead 2 plus, or mercury 1 plus cations, and if the answer is affirmative, then the compound is insoluble. However, all the other chlorides, bromides, and iodides are soluble, and so on and so forth, along the line. Now, there are many of the ions in the ions chart of KembloX that are missing, which means that the compounds, the ionic compounds containing them, would probably be insoluble. The dissolution of ionic compounds occurs through a very simple process. The dissolution process is when an ionic compound dissolves, the ions that make up the compound come apart in the process. We'll use KembloX to illustrate this process and try to help avoid common misconceptions encountered in the classroom. When dealing with two ion compounds, there is little room for confusion. A good example is table salt sodium chloride, NaCl, whose KembloX model is shown. As we see, the two ions, sodium ion and chloride ion, come apart as ions, i.e., they keep their charge. After coming apart, they move independently in the solution, and this process can be symbolically represented by a formula in which sodium chloride dissociates into two ions. For more complex ionic compounds, the number of imaginable dissociation patterns increases. For example, even for the 3-ion magnesium chloride, whose formula is MgCl2 and whose KembloX representation is shown, there are several possible dissociation patterns, each of them deemed acceptable by certain students, with only one of them being the correct one. In the first clip, we see a pattern in which only one of the two chloride ions separates from the formula unit, and then there will be a magnesium chloride plus combination and a chloride minus ion moving freely in solution. In symbolic form, that looks like this. In the second clip, we see a pattern in which magnesium plus 2 ion, magnesium ion, and the 2 chloride ion separate from each other. However, in this pattern, the 2 chloride ions stay together and behave as one entity when moving through the solution. The process can be symbolically represented as a dissolution in which we have one magnesium 2 plus ion and one ion chloride 2 minus 2 ion. Finally, in the third clip, we see a pattern in which the magnesium chloride separates into 3 ions, each of them moving independently through the solution, 1 magnesium ion and 2 chloride ions. The last pattern can be symbolically represented as magnesium chloride dissociating into 1 magnesium 2 plus ion and 2 chloride minus ions. Of all these patterns, only one is correct. The first one and the second one are not correct. However, the third one is the correct one, and it is the only way in which dissolution occurs. In summary, we presented 2 points. We tried to make 2 points. One is that in order to assess the solubility of an ionic compound, one can use a KembloX chart and the solubility guide presented in this segment. The second, even more important, is that the dissolution of ionic compounds occurs such as to result in the maximum number of ions in solution. This concludes another segment in the series of using KembloX for modeling ionic compounds.
With KembloX I learn easily when I study chemistry. Chemistry for you and me. KembloX does the trick for me.